350 million years ago, Dunkleosteus, the fish with the most powerful bite of all time, disappears from the fossil record. Soon, sharks would rise to take Dunk's niche as top predator. Why did sharks survive and Dunk fail? The earliest sharks were probably lunch meat for Dunkleosteus.
Sharks weren't always the top predator. Based on the fossil record, we believe that sharks have been around roughly 430 to 450 million years. And they've been around longer than any other group of vertebrates on the planet today.
Biologist Dan Huber's fascination with sharks started early.
When I was about 8 years old, a relative of mine was attacked by a shark while surfing off the east coast of Florida. And it just caused this tremendous curiosity in me, and I grew up hanging out by the shark tank at the New York Aquarium.
In the hunt for clues to the shark's survival, Dan Huber set out to make the first detailed scientific measurements of the shark's bite. Instead of using a potentially dangerous live shark specimen, Huber got his hands on the head of a dead sand tiger shark that got tangled in a fishing line. His aim? Construct a precise virtual shark jaw inside the computer and study the bite from the safety of a desk chair. The first step to modeling the jaw is a high-resolution CT scan.
Using these types of modeling techniques, we can actually get estimates of the maximum performance or maximum bite force of animals like sharks.
The system produces a digital version of the shark's skull and an accurate foundation for the computer model. Next, Huber dissects his specimen, carefully measuring each muscle that powers the jaw. The muscle data is then overlaid onto the CT scan's skeletal blueprint, and together, bone and muscle form a complete 3D virtual jaw. The cyber shark is now ready for its virtual, numbers only, bite. When the numbers are crunched, they reveal a surprising fact.
One thing that might surprise some people is that pound for pound, if we compare them to historical predators like Dunkleosteus, for example, they really don't bite all that hard.
The sharks Huber modeled only produced bite forces of 500 to 600 pounds, less than half the power of Dunk. So if sharks can't dominate with biting power, why have they been so successful? For biologist Cheryl Wilga at the University of Rhode Island, the answers begin with a body built for speed.
Think of a shark swimming really fast, chasing its prey. It has this nice hydrodynamic torpedo-shaped profile, which allows them to very quickly maneuver in any direction.
Sharks have no bones to restrict their flow. They are built almost entirely of the kind of flexible cartilage we have in our nose. And the shark's jaw placement, neatly tucked low and back, reduces drag. Wilga's after the first microsecond analysis of how the shark bite works. She's studying a small, relatively docile shark called the spiny dogfish. To capture the lightning-quick bite, Wilga sets up a special slow-motion video camera. And then the bait, a slice of herring.
She took it. All right. Head shaking. That's pretty good.
A close-up examination of the video reveals the 5-step shark bite, unique in all of nature. Wilga replays the 5-part shark bite with a live and sedated dogfish.
What you see when the shark is swimming is this nice smooth profile here. And when he comes up to food, he elevates the cranium, he depresses the lower jaw, and then protrudes both the upper and the lower jaw away from the cranium. Now when they're done feeding, Everything goes back underneath the cranium, and there's a nice smooth profile again. And all this happens in 50 to 70 milliseconds.
The scientists call it jaw protrusion. It gives the shark a small but important advantage.
You can equate this to, say, a sprint race. If the shark can thrust out its jaws just that much further to grab the prey, he's the winner by far. Just that little bit makes a huge difference.
Sharks were fast. Shark jaws could reach out. And sharks evolved teeth perfectly suited to their task.
Back in the day, sharks had small, tiny, ice pick-like teeth, more for grasping than anything else. But as several different groups evolved, teeth became bigger, but more importantly, it's the shape of the teeth. If you have a big triangle-shaped tooth that's serrated like a steak knife, it's easy to jab a steak knife into the prey.
Razor-sharp shark's teeth also have evolved the amazing ability to regenerate throughout the fish's lifetime.
And in fact, the teeth are so sharp that you generally have to wear some kind of heavy-duty glove in order to get close to them. And you can kind of see, as we open up the jaws, there's the teeth that are up front. That's the row of teeth that they actually use to capture their food. But behind each of those functional teeth, there's 6, 7, even 8 teeth waiting to pop into place like a conveyor belt. So that as a shark captures its food and teeth can get ripped out, sharper teeth are ready to pop right into place so that they can keep on hunting without missing a beat.
By any measure, one of the most successful life forms of all time, the shark has remained the top predator of the seas for over 300 million years. Its jaws unmatched. But successful evolution is about the right tools for the right environment. A new kind of jaw would evolve when one lineage of fish took a bold step and moved onto dry land.